So let me start off with looking at some data. In terms of the first question that I asked, what is the most effective thing that you could do in your life to conserve energy? 20% of my participants said turning off the lights. This is the most effective thing that they could do. Followed by just conserve energy, recycling, sleep more, relax more, and there's just no way, I don't know how to do it. So there's a whole wide gamut. But in terms of the most effective thing, turning off the lights was the big one. And turning off the lights doesn't save as much energy as you would think of in terms of energy efficiency. So if you were to take all of these behaviors and divide them up into energy efficiency and curtailment, we'd sort of see a different pattern. Now, energy efficiency is actually switching technologies. So you don't necessarily have to change the way you use a particular technology, but you just switch a technology. So for example, using an efficient car. You can still drive the same amount that you drive, but you just drive it in a more efficient way. Alternatively, you can think about curtailment. So it's basically using the same technology, but just using less of it. So if you think about curtailment, 55% of the participants stated curtailment as the most effective thing that they could do. Only 12% stated energy efficiency. And this is in stark contrast to what experts recommend in terms of what it should be most effective, where experts actually say that energy efficiency is way more effective than curtailment when it comes to decreasing energy consumption. So this was the first misperception. Then I asked individuals, all right, rank order these 4 different containers, these 4 different beverage containers, and how much energy is used to make them. So just rank order them. Just tell me which one uses more energy than the other. So I asked them about a virgin aluminum can, virgin glass bottle, recycled glass bottle, and recycled aluminum can. So it's just recycled versus virgin, aluminum can versus glass bottle. And these are things that we use every single day. Like I'm using one right now. And so what you notice is this, if data lies along this dotted line, that means people's perceptions are accurate. What you notice is people think that the amount of energy that goes into making a recycled aluminum can is almost the same as the amount of energy that goes into making a recycled glass bottle, when in fact, a recycled aluminum can uses 20 times less energy. And the reason is that the aluminum process, manufacturing of aluminum process, uses a virgin aluminum can requires 90% more energy than a recycled aluminum can. So if I had a limited amount of effort, and if I had a choice of recycling one of these, I'd probably do either one. But you should almost always recycle an aluminum can if you can. So that's another misperception in the population. And this is especially important because ever since you're a kid in this country, you're taught recycle, recycle, recycle. But people don't really know how much energy is saved by these different things. Then I asked individuals, rank order these 4 different means of transporting goods for 1 ton of goods for 1 mile. So how much energy do you think, what is the rank of airplane, truck, ship, and train to just transport 1 ton of goods for 1 mile? So people get airplane right. An airplane does use the most amount of energy within these 4. But they think that a truck uses the same amount of energy as a ship or a train to transport 1 ton of goods for 1 mile, when in fact, a truck uses 10 times the amount of energy. So if you were to go to FedEx and you were able to choose between transporting your book from Amazon or wherever via truck or via train, you wouldn't be able to differentiate these 2, when in fact there is a huge energy savings if you were to choose one over the other. Now I asked individuals, and this is more related to this particular group, is that of these different devices or behavior changes that you could do in your home, how much energy would be used or saved in an hour? So on the y-axis, you have perceived energy used or saved in watt hours. On the x-axis, you have actual energy used or saved. The diagonal where y is equal to x is where perceptions match actual. So if I were to ask you this, you'd probably get most of these devices right. So your data points would probably lie along this diagonal line. So and this is a replication of the risk curve that Sarah Lichtenstein did. So if you were to look at these smaller behaviors, people roughly get them right. They roughly know how much energy lighting uses, a stereo uses in an hour, or a desktop. But if you look at these larger behaviors, people severely underestimate them by orders of magnitude. So this y-axis is actually a logarithmic curve. So let me walk you through 2 specific examples in this data. Let's look at an electric clothes dryer. an electric clothes dryer is underestimated by one whole order of magnitude. Then let's look at laptops and desktops. People think that laptops and desktops roughly use the same amount of energy in an hour, when in fact a desktop uses quite a bit more. So what this means is that if you try to get your residents to conserve energy in their homes, you really need to somehow try to pull this curve up to try to get them to understand how much energy these different devices use, because they really underestimate them. They get the ordering roughly right, so they do guess that an electric clothes dryer uses more energy per hour than a stereo, but they don't really understand by how much. So does this graph make sense? All right. So then I tried to, sorry, let me go back. So then what I did was for each and every one of the 505 participants in my group, I created a regression curve to trying to figure out what are the particular characteristics of this individual that predict accurate perceptions. So what is it about you that makes you more accurate in terms of how much energy you think is used in a particular hour by these different behaviors? So now let's look at the data. So what we find, so these are parameter estimates for a whole variety of these different predictor parameters. Just focus on the ones that are in color. The ones in color are the ones that are statistically significant. So the first one that is statistically significant is numeracy. So it's in color for two of the separate regressions. Now what numeracy is your ability as an individual to understand quantitative numbers. So if I were to tell you 1 out of 10 people can win a lottery, how many people out of 100 would win a lottery? You'd be able to tell me the answer correctly. So numeracy is a good predictor for accurate perceptions. The other thing that is statistically significant is pro-environmental attitudes. So if you have pro-environmental attitudes, you're more likely to be able to have accurate perceptions of energy consumption. Now here is the surprising finding. If you look at environmental behaviors, it's negative and statistically significant. So what this means is that if you currently incorporate some environmental behaviors in your life, you have worse perceptions of energy consumption. Now, what this could imply, and one hypothesis that we're trying to investigate further, is that you might just be focusing on the 1 or 2 behaviors that you currently do and sort of discounting the rest of the behaviors. So let's say you have the curly bulb at your home. So you think that might be saving a lot of energy, and everything else, very little. So it's sort of self-gratification. You're doing good, basically. So this is a surprising finding. So in terms of conclusions for this particular study, for the most effective action, participants think energy efficiency rather than, participants think curtailment rather than energy efficiency, and that is in stark contrast to what experts recommend. In terms of major misperceptions of energy consumption, people have small overestimates for low energy behaviors, but they have huge underestimates for large energy behaviors. And this is something you, as people that run buildings, will really have to work towards trying to correct and change. People think that the amount of energy used by a train, truck, and ship is almost the same, where in fact a truck uses 10 times that energy. People think that a recycled bottle is equal to a recycled can in terms of the amount of energy going into manufacturing, when in reality a recycled glass bottle uses 20 times that amount of energy. So participants who are more numerate, who are able to think about quantitative numbers correctly, and who are pro-environmental have more accurate perceptions. Participants who currently engage in environmental behaviors have worse perceptions. And one hypothesis for that finding could be the focusing effect.